In this slide, we're taking an in-depth look at CVE 2024-3863, a severe vulnerability identified within the Windows TCP IP stack. This vulnerability is particularly concerning because it allows remote code execution due to improper handling of IPv6 packets. It's classified as a critical remote code execution vulnerability with a CVSS score of 9.8, highlighting its severity. This vulnerability impacts a broad spectrum of Windows operating systems, including versions from Windows 10 to Server 2022. Understanding this vulnerability is essential as it underscores the importance of proper packet handling to prevent unauthorized code execution. In the technical exploration of CVE 2024-3863, we identify the root of the issue as an integer underflow during the processing of IPv6 extension headers. This oversight can result in a buffer overflow, which in turn permits arbitrary code execution. Attackers exploit this by dispatching specially tailored IPv6 packets that capitalize on weaknesses within the TCP.sys driver of Windows systems. By crafting these specific packets, they can initiate unauthorized actions, leveraging the core vulnerability identified here. Understanding this mechanism is vital for the development of effective mitigation strategies and protective measures against such remote attacks. This slide focuses on the systems affected by the vulnerability. The impacted Windows versions include Windows 10 and 11, as well as Windows Server editions 2016, 2019, and 2022, even covering core installations. This vulnerability is particularly alarming due to its network exploitability, which does not require interaction from users. Because of this characteristic, it is categorized as wormable. This means it has the potential to propagate through networks autonomously, similar to a worm, posing a significant threat to large-scale infrastructures. As such, understanding the breadth of affected systems underscores the importance of addressing and mitigating this vulnerability in a timely manner. In this slide, we're going to explore a demonstration of how CVE 2024-38063 can be exploited using SCAPI, a powerful tool for working with network protocols. Here we've crafted specific IPv6 packets that highlight potential vulnerabilities within the system. As shown, we can use SCAPI to send these packets, such as through the sendp function. An example packet might involve Ethernet, IPv6 headers, and destination options, illustrating how a payload can be manipulated. Another example is a fragmented packet, which can include headers that may lead to a buffer overflow when malformed packets are processed incorrectly. The provided proof of concept POC emphasizes the potential for causing buffer overflow. This POC serves as a practical illustration of how crafting specific packets can potentially exploit vulnerabilities, emphasizing the importance of understanding these risks to implement effective security measures. In this slide, we're focusing on mitigation strategies for addressing vulnerabilities like CVE 2024-38063. First, it's imperative to apply Microsoft's August 2024 security patches to ensure that any known vulnerabilities in the software are addressed promptly. For temporary measures, consider disabling IPv6 on your network unless it's absolutely necessary. This step can help reduce the potential attack surface that malicious actors might exploit. Furthermore, it is vital to consistently monitor your network for any unusual IPv6 traffic. Keeping an eye on traffic patterns can help you quickly identify and respond to any suspicious activity, potentially preventing exploitation before it causes harm. These steps, while part of a broader security strategy, are essential in providing immediate protection against known threats. When it comes to ensuring your systems are protected, applying security updates is a fundamental step. There are several methods to ensure your systems remain up to date. For individual or small-scale updates, you can use Windows Update by navigating to Settings, then Update and Security, and finally selecting Windows Update. For larger networks, deploying updates efficiently can be achieved through Windows Server Update Services, WS, or other corporate tools, which streamline and automate the process across numerous systems. Alternatively, if you prefer or require a more hands-on approach, manual installation of patches is possible by downloading the necessary updates directly from the Microsoft Update catalog. Each of these methods ensures that vulnerabilities are patched, maintaining the integrity and security of your systems. Having explored various methods to apply security updates, we now turn our attention to best practices for maintaining a secure system. System hardening is essential. This involves ensuring systems are consistently updated and disabling any unnecessary services, such as IPv6, if they are not being utilized in your network. By doing so, you can minimize potential vulnerabilities. Additionally, network monitoring plays a significant role in security. Implementing intrusion detection systems allows for the identification of malicious IPv6 traffic patterns, helping you stay ahead of potential threats. These practices, when used together, contribute to a more secure and resilient environment. In this section, we're concluding our discussion on the CVE 2024-38063 vulnerability. This particular issue is a critical remote code execution vulnerability, and it demands immediate attention. Therefore, it's imperative to apply the latest patches as soon as they are available to safeguard your systems. Apart from regular updates, one of the key recommendations is considering the temporary disabling of IPv6. This can be an effective measure when IPv6 isn't being utilized, providing an additional layer of defense against potential exploits aiming to target this vulnerability. It's essential to stay vigilant and proactive to keep your systems secure against emerging threats. For anyone seeking further information on CVE 2024-38063, we've provided several key references on this slide. Firstly, Microsoft Security Advisory offers official details and guidance directly from Microsoft regarding this vulnerability. Additionally, you may want to explore the GitHub POC repositories, which offer proof-of-concept code to help understand the vulnerability's practical impact. Finally, analysis reports from Tenable and Rapid7 can provide deeper insights and professional assessments of the vulnerability, contributing to a better understanding of potential risks and resolutions. Leveraging these resources will be invaluable for anyone aiming to protect their systems effectively.